Hello everyone, welcome to my YouTube channel. It's me Rituparna Das. Now I'm an undergraduate student from Shahjalan University of Science and Technology in Department of Economics. Imagine conducting a study on a large population. How do you ensure accurate result without surveying every single person? The answer lies in effective sampling and data collection methods. So my today's video is about sampling design and data collection methods. If you are someone who is enthusiastic about different topics of research, then this video is for you. So let's get started. So what can you learn from this video? This video will explore sampling and inference, types of sampling, sampling design, systematic bias and systematic error, and the last types of non-random sampling. My first topic is sampling and inference. So what is sampling? The process of selecting a subset from a larger group, that is population, is sampling. Instead of studying an entire population, researchers use sampling techniques to collect data more efficiently. There are two types of sample. First, random sampling, and second, non-random sampling. In the random sampling, every individual has an equal chance of selection. For example, simple random sampling and stratified sampling. And in the non-random sampling, selection is based on criteria or accessibility. For example, convenience sampling and quota sampling. Now, what is inference? Statistical inference is the process of drawing conclusions about a population based on information from a sample. It helps estimate population characteristics and test hypotheses. There are some key concepts in inference. These are estimation, sampling error, confidence interval, and hypothesis testing. Using sample statistics to estimate population parameters is the estimation. For example, sample mean estimates population mean. Sampling error is the difference between the sample statistics and the true population parameter. Confidence interval is the range in which the true population parameter is likely to fall. And hypothesis testing evaluating claims about a population using sample data. A sample design is definite plan for obtaining a sample from the population. Sample design is determined before the data are collected. Researcher should prepare a sample design that is reliable and appropriate for his or her study, considering the following points. First, types of population. A sample design should clearly define the set of objects technically called the universe or population. Second, sampling unit. The researcher has to decide the sampling unit for the study. The sampling unit may be individual, social units such as household, geographical such as country, district, or village. Third, sampling frame. Sampling frame contains the name of all items of a universe. In case of finite universe, such a list should be comprehensive, reliable, appropriate, and most importantly, as representative of the population as possible. Fourth, size of sample. The size of sample refers to the number of items to be selected from the population. It should neither be excessively larger nor too small, rather be optimal. And not last, parameters of interest. Sampling design largely depends on the parameters of interest. The next topic that I'm going to describe is systematic bias and sampling error. There are two costs involved in sampling, the cost of collecting data and the cost of an incorrect inference resulting from the data. Incorrect inferences arises as a consequence of two reasons, such as systematic bias and sampling error. A systematic bias results from errors in the sampling procedures that cannot be reduced by increasing the sample size. There are some factors that are responsible for systematic bias. Number one, inappropriate sampling frame, when sampling frame is biased representation of the universe. Number two, defective measuring device. When data collection tools are biased, physical measuring device is defective or data collector is biased or weak in calculation. Number three, non-respondents. When a researcher is unable to contact with the individual initially included in the sample. Number four, spotlight effect. When respondents act differently when kept under observation than what they do when kept in non-observation situation. Overt and covert observation may give different outcomes. And number five, natural bias. Respondents are either downward or upward biased for some variables in questionnaire depending on the nature of the question. Here you can all see a diagram of sampling error. I include this diagram so that the concept of sampling error can be easy for all of you to understand. The diagram shows nested circles where errors accumulate at different stages of sampling. Here, sampling error is equal to frame error plus chance error plus response error. If we add measurement error or the non-sampling error to the sampling error, we get total error. The magnitude of the sampling error depends upon the nature of the population, minus the more homogeneous the population of the smaller the sampling error. Sampling error is inversely related to the size of the sample. Sampling error decreases with the increase in the sample size and vice versa. Measurement of sampling error is called precision, which can be improved if we increase the sample size. However, larger the sample size, higher the cost of data collection and thus higher the magnitudes of the systematic bias. Therefore, a researcher must choose a sampling design that generates small sampling error and controls the systematic bias effectively. I have already explained this. If you don't understand my explanation, then you can give it a pause and give it a read for 2 or 3 more times. Then you can surely understand it. So next, we will learn about non-random sampling. Non-random sampling, also called non-probability sampling, refers to sampling techniques where not every member of the population has an equal chance of being selected. There are some types of non-random sampling, convenience sampling and judgmental sampling. Convenience sampling is selecting participants who are easiest to access. For example, serving people at a shopping mall. There are some pros and cons of convenience sampling. It is quick and cost effective, and the cons are high risk of bias, may not represent the entire population. The second is judgmental or purposive sampling. Researchers select participants based on expertise or criteria in this kind of sampling. For example, interviewing industry experts for market research. This sampling also has some pros and cons. Useful for specialized studies, this is the pros, and cons are subjective. Researcher bias can influence result. Next two types are quota sampling and snowball sampling. Ensuring specific subgroups are represented in the proportion, which is quota sampling. For example, selecting 50% of men and 50% of women in a study. The process ensures diversity and the cons are still non-random. Selection within groups may be biased. And the last is snowball sampling. Existing participants recruit others they know. It is snowball sampling. Example, studying a rare disease where participants refer to other patients. The pros are useful for hard to reach populations and the cons can lead to biased, non-generalizable results. Next, we will learn about random or probability sampling. So as I said earlier, random sampling, also called probability sampling, is a method where every member of the population has an equal chance of being selected. This ensures that the sample is representative of the population, reducing bias and allowing for accurate statistical inference. There are 5 types of random sampling. First one's simple random sampling, stratified random sampling, systematic random sampling, cluster sampling, and lastly, multi-stage sampling. Here are the description of these types of sampling. First, simple random sampling. Here, every individual has an equal chance and independent chance of selection. For example, assigning numbers to a student and using a random number generator to pick participants. There are pros and cons of simple random sampling. Eliminates bias, easy to implement, and cons requires a complete list of population. Number 2 is stratified random sampling. And in this kind of sampling, population is divided into subgroups, for example, strata, based on the characteristics, for example, age or gender, and a random sample is taken from each. Example, a researcher studying employee satisfaction selects equal number of male and female employees. Pros ensures representation of key subgroups, and cons requires prior knowledge of population characteristics. Number 3, systematic random sampling. In this sampling, selects every kth individuals from a list after a random starting point. For example, choosing every 10th visitor entering a shopping mall for a survey. Pros easier than simple random sampling, and the cons can introduce bias if the list follows a pattern. Next is cluster sampling. In this sampling, the population is divided into clusters like cities or schools, and entire clusters are randomly selected. For example, a study on school performance selects 10 random schools and surveys all students in those schools. Its pros, cost-effective, useful for large population, and answer may not fully represent the population if clusters differ significantly. And the last is multi-stage sampling. In this sampling combines multiple random sampling techniques. Example, a countrywide study randomly selects cities, cluster sampling, then randomly picks individuals from each city, like simple random sampling. Pros are efficient for large-scale studies and cons are more complex to design and analyze. So that's all for me. If you want to know something or if you have any confusion, let me know in the comment box and you can comment in the comment box. And if you like the video and helpful for you, you think, then do like, share and subscribe. Thank you.